Hello everybody, welcome to the school project, where this project was made by me, and a few other people. Now what we want to talk about right now is roller coasters. Now roller coasters are super expensive, but they're super fun, and we wanted to get one for school, test it on some subjects, possibly kill them in a crash, the works. But apparently we couldn't do that, so we had to settle for a marble, which will be represented by this gray circle. Say hello to the circle. Hi circle. Too bad, it's going up here. It's going to go away from you because you're bad. It's also going to go up here because this is going to be the maximum height of our roller coaster. Now, to get the maximum height of the roller coaster, you want to go to, the very top. As you can see here, the tip of the index finger is going to represent the very top, or it is. And this is going to maximize the amount of potential energy that is going into this roller coaster. Now, as you can see at the very bottom, there's an arrow pointing straight over there. That is going to represent the very base. That is our height 2, by the way. And at the very end, that is going to be the most amount of kinetic energy we have at that point. Now, moving on, we can see with these arrows that the amount of potential energy is increasingly high at this point. Not increasing yet, but it won't increase when it goes down. The amount of kinetic energy, or the energy of motion, is not really activating right now. So, as we can see, potential energy, big, kinetic energy, small. Here's labeling. Now at the very bottom, in the bottom right, as you can see, the amount of kinetic energy has grown very much, and all the potential energy has been transferred into the kinetic energy as gravity has pulled it down along a slope in order to increase its motion with acceleration. That's kinetic energy. The potential energy, sadly, just went away. Oh no! But it's not all gone because it's not the center of the Earth. Yay! Potential energy is conserved. Also, all this is called mechanical energy. Now, as you can see, we have our findings. The mass of the marble that we used was 0.0054 kilograms. The height, or the maximum height, 1 of our roller coaster is 1.34 meters. The second height, the base, as I mentioned earlier, is going to be 0 meters. Now, our first velocity, since we haven't moved it yet, is going to be 0 meters per second. We are going to find velocity 2 with each other. I am popping my knuckles right now because I am getting very fidgety and stiff. Alright, so the acceleration of gravity downward is going to be 9.8 meters per second squared. But we don't really need to know that because I'm going to be doing all the math for you. There are the formulas if you want to figure it out for yourself, but first we are going to be going into mechanical energy. Now the mechanical energy at the beginning of the ride and at the end of the ride is going to be saying the same, because conservation of energy, blah blah blah, can't break physics, go screw yourself. Sorry. But here's what we're going to be doing. In order to get mechanical energy, we need potential energy and kinetic energy. And since we only have one of those and the other two are just zeros, we're going to be getting rid of them so you don't need to pay attention to them. But what we really want is the kinetic energy of the second state. Now, this is very simple. You just put them up like this, 0, 0, get rid of those. And then we have the joules for kinetic energy. Joules are basically representations of the amount of energy that is in an object, or in this case the amount of motion it's creating, and then we're just going to leave it like that for a little bit. Now if we go down here, we can figure out how much velocity is in this by deconstructing the formula. As you can see in the top, the formula for kinetic energy is half the mass times velocity squared. I put that there because I can't square on this computer and it's weird. Especially on Google Slides, which I'm using right now. Hooray, I'm smart and conserving energy because I'm not going to edit this entire video and I'm doing it in one take. Oh no! Alright, so after that we are going to be dividing the thing on the left, the 0.071 joules, algebraically by 1/2, which is going to give us 0.142. We're going to leave that number just as it is because we don't really know what it is anymore. Even I don't. I'm so lost. By the way, after that we are going to be moving the mass over and we are going to be dividing by the mass, which is, coincidentally, another fraction. So that's going to boost the number up again. That's going to be 26.3. Now, the velocity, we haven't figured it out yet because it's been squared. So, what we're going to be doing is getting the square root of this, which is going to be 5.13, and that's just going to be meters per second because I didn't write that down. As you can see, in Velocity 2, we put it in, so now we have the complete information. There you go. Also, we really want to do a lot of this, a lot of this experimentation, you know, it's to keep families healthy and living and not worshiping a dead god, you know, all the usual stuff, and keeping the family alive, which I don't really agree to, but whatever. And as you can see here, the happy face indicates to us that the loops must be regular in order to, you know, minimize any energy loss. This is a very fun fact that we found on our extra experiments, because if you do too much of a loop, it will lose all of it. As you can see with my mouse, and then at the very top here, when it loses everything, it'll just fall down. This happened quite a lot, but we learned from experience. Also, a lot of this can be eliminated by just making the loops super tiny. But remember, the angles can't be that good. Not the angles being not that good, but what I want to say is, not jumping over my words, if you make smaller loops, you'll get faster results. Then they'll go faster. Now, I love physics, and I love math, and I love doing all this, and I love video editing, but not really. So I'm not going to be editing this video. This is the raw footage, and I just did it in one take finally after about 10 tries, and I hope you guys have a great day. And I really want to know, if you guys are watching this, should I do an easily explained physics series? This would be a very great opportunity to, you know, get fast videos out and, well, grow the channel while at the same time working on other things. Yes, I'm doing other things. Wow, weird how that is, right? Anyway, I'll see you guys later. Goodbye.